Welcome everybody to week 6, day 2. We're having a short lecture today because we are doing something cool, something interesting. We are doing a coding competition. If you're watching this recording live, you missed class, sucks to be you. You missed it. So this is something that is a timed event. And so before we get to the timed event, I'm going to give a very short lecture on something I forgot to talk about, which is called function overloading. So you can have two different functions in C++ that have the same name, okay? And this, how does it disambiguate? How does it know which one to choose? Well, if you pass a pair of integers to it, then like this, if we cout add 3, 4, yeah, exactly, Alessandro. If you pass in integers to it, then it will call the integer version. If you pass the double version to it, it will call the double version, okay? And so it calls the integer add, then it calls the double add. Now, an obvious question is, what if you have one of each? For example, if you have the double in the first slot and an int in the second slot. And the answer is, well, you can probably see what the answer is here. It doesn't know which one to pick. Because what it has is it puts together a list of all of the candidates for calling add. And so it says, okay, I've got one add that's got two ints. I've got one add that's got two doubles. I'm passing one int, one double. They're both kind of like one step away. And it doesn't know. It doesn't know which one to call, and so it just errors. It says the call is ambiguous. Now, if I only had one version, like this, it'll actually work fine, because it will convert the double to an int, and that's fine. You can convert implicitly from a double to an int, or an int to a double. That's fine, and it actually doesn't matter which one of these I comment out. If you do it this way, then these will get converted to doubles. If you do it the other way, these will get converted to ints. But if you have both in there, then it's the parameters that it uses to disambiguate from it. Now, some people think that this matters, like double x is equal to add 3 and 4. Some people think the return type matters, and it doesn't. If you do this, it's going to call the integer version. Okay, I'm sorry. Let's put this back to double. So you see it calls the integer version, right? Even though we're getting the return value of the double, doesn't matter. The return type does not count for function overloading. It's ignored, basically. So the only thing that matters is the name of the function and the parameters you pass in. So if you have a function named add, you pass two integers in, it calls this version. If you have a function named add and you pass in two doubles, it calls this version. It does not matter what the return type is, okay, at all. It just doesn't count. So let's do a couple more examples. What if we pass in a short? So a short, for those of you that don't know, a short is a signed 16-bit int. A short 16-bit gives you 2 to the 16th power, which is like 65,536, something like that. And so if you have a signed number, it goes up like plus or minus 32,000 and change. So which one do you think this is going to call? So it's obviously compiling here. Do you think it's going to call the integer version, the 32-bit integer version, or do you think it's going to call the 64-bit floating point version? Take a vote now. Operators are standing by. It's compiling. It's going to pick one of them. There's no exact match. And so it's got rules for like, all right, which one is closer? What's closer to a 16-bit integer? Is a 32-bit integer closer, or is a 64-bit float? Yeah, you guys all got it. It's going to call the int version of it. I can run it if you want. It's going to call the int version there. Okay. What if we pass in capital A and capital Z? Which version is this going to call? I'm passing in a char. Chars are like letters, right? Chars are not letters. Chars are a char is a signed 8-bit integer. This single quote business where you're talking about a letter, that's all a lie. That's a lie sold to you by big char and their string factories. There is no such thing as a letter. It's just an 8-bit number. And whenever you have a single quote like this, you're exactly, yeah, Big English. Big English sold you on this lie. It's not a letter at all. It's a number. Okay. And that's why, like, you can't, like, if you try doing this, like, character C is equal to double quote S, like, it doesn't work. You're like, but it's a letter. It holds a letter, right? Nope. A string and a char are actually quite different things. Likewise, you know, if you say string S is equal to single quote C, it doesn't like that either, right? Because this is an integer, it's not a string. Okay. So yeah, a char is assigned 8-bit. If we run it, yeah, it's int because it is closer. A 8-bit integer, as you can see, is closer than a 16-bit or 64-bit float. What about if we do a char in the first slot and a double in the second slot? Okay, it's kind of answer. Thank you, Commander of Conqueror. What about this one? We got, yeah, it's in there. What about a char in the first slot and an int in the second slot? Yeah, that's an int. What if we do a float? So a float is a 32-bit float. Double is a 64-bit float. Which one do you think this is going to call? Is a 32-bit float closer to a 32-bit integer, or a 64-bit floating point number? And the survey says it is a double. Okay. So you guys understand, like, the rules are pretty straightforward. You can get into some weird ambiguous calls sometimes, you know, if you try, like, mixing and matching, like, you know, things like this, like, you know, you'll get into trouble. Yeah. But pretty straightforward, I think. Not too bad. Some students in class were asking about, like, what's the size of a char, what's the size of a short, what's the size of an int, what's the size of a long, what's the size of a long. And the answer is it's not actually defined in the standard. If you have ever done C# or Java programming, these things are actually fixed sizes. An integer is always 32 bits in Java and C#. In C++, it's platform specific. I used to actually work full-time porting C++ code from one platform to another. So you take your code, which works just fine here, and put it on the system over here, and it doesn't compile. You get like 9,000 compile errors. And then you fix the compile errors, and you run it, and it runs fine for a while, then it crashes. You're like, why the hell is it crashing? And, you know, you can take your code from one system that has 32-bit integers and run it on another system that has 16-bit integers. That's happening less these days because of that problem. Like, you take code that expects for integers to be 32 bits, which gives you numbers from like plus or minus 2 billion and change. And if you shrink them down to 16 bits, you know, you're playing Grand Theft Auto and your score goes, your money score goes over 32,000. All of a sudden you're at negative 32,000. You're like, what? You know, and so, like, it compiles, it runs, and then it just runs badly after a while. And so most modern platforms have 32-bit integers, at least if you're talking about like PCs and things like that. Like, I haven't seen any system recently that has anything but a 32-bit integer, just because of those problems, you know. But yeah, it is perfectly legal for you to go to a platform that has 16-bit integers. And so I don't like using, because remember, this is what I did for a living, right? I don't like it when I take my code from one platform to another. Now, one where it does change is this. So on our platform here, a long is 64 bits, and on a Raspberry Pi, it's 32 bits. On a 32-bit Raspberry Pi system, it's 32 bits. And so the size of a long will actually change if you take CSI 40 code and you go to CSI 45, where, you know, I've got a Raspberry Pi here. If you run your code from CSI 40 on here, the size of a long will change. True story. So I don't like using long and int and things like that. I mean, I'll use an int, like, if I have to count to, like, you know, count to 30 or something. Like, an int's fine. Like, it's not a big deal. But, like, if like, you're expecting integers to, you know, have a certain maximum range, I don't use int. So the solution is to do something like this. You can say, give me an unsigned integer 8-bit, give me a signed integer 8-bit, give me an unsigned integer 16-bit, give me a signed integer 16-bit, give me an unsigned 64-bit, 32-bit for completeness, give me a signed 32-bit, give me an unsigned 64-bit, give me a signed 64-bit. And so you specify directly, I want a 16-bit number, and it gives it to you. That way you don't have to worry about platform-specific changes in sizes. This is just the right way of coding if the upper bound on your variables matters to you. Sometimes it doesn't. Like if you're just doing a for loop from like 0 to 100, just use an int, who cares? Like the size of an int is actually picked to be whatever is fastest for your platform. And so, I wouldn't use a short even. I wouldn't use a char. I would use an int. Even if I don't need all 32 bits or whatever, if I'm just going to do a for loop, for int I equals 0, I is less than 101, I plus plus, we're just going to count from 0 to 100, I'm going to use an int, because that is the fastest type for our platform. But anytime, like if I'm going to be storing up to, 1 billion or so, like I'm storing social security numbers, I'm not going to use an int. Because I want to guarantee that I can actually store the numbers that I think I can store. So C++ isn't good for copying and pasting. I mean, that was what it was designed for. It was designed to be a platform-independent programming language where you can take your code from your IBM mainframe and run it on your PC, and the same code would work the same way. In theory. Java was designed the same way, too. Java was under the premise that you could write a Java program once and it would run on every platform the same, which was a lie. C++, in theory, is platform independent. In reality, though, you're going to have like header files up here that only exist for Windows or only exist for Linux. And so you try porting from Linux to Windows, those header files don't exist anymore. And then, there's a big sigh. Or you port between different versions of Unix, and they have different ways of like getting the time. Like doing a high resolution timer is different on different versions of Unix. And so that's why I was hired, was because I understood the different, differences. And even then I would be baffled, like what? It was a job, it was a legitimate job. Okay. So yeah, in theory, in theory, it should work the same on every platform. In practice, it doesn't. So I like doing these. If I actually need to know, like I want to have 4 billion numbers, I use an int 32. Okay, so that's the more proper way of doing it. Most of the time, though, an int's going to be fine for normal human needs. Okay. So what we're going to do now, system clear does not work on Windows. That's right. Yeah, system is part of the Unix. Actually, it's part of the same library. Yeah. So, but clear. Yeah. So on Windows, it's CLS. So if you want to clear the screen on Windows, it's CLS. I actually have an alias on Unix to clear because it's the same command, but it's one of the few instances where DOS actually has a smaller command name than Unix. So yeah, if you do a system CLS, and there's no pause in Unix either. Like if you look at most Windows code, like they'll finish with like a system. They'll end with like a system pause or something like that. Like if you see that, that was written for Windows because it doesn't exist on Unix. And so that's the kind of thing that, like, makes porting fun. It's not fun, but it's a job, and you learn a lot too.